Well, good afternoon, good evening, or good morning, depending on where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. Before we get started with today's webinar, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you'll be receiving a link via email that will take you to the webinar on demand. And we will be asking questions today during the webinar, taking audience questions. So if you have a question for our panelists, please feel free to use that control panel and submit your questions at any time. We'll take a few minutes near the end of the event and go through those audience questions. Okay, and with that, we will go ahead and get started with today's webinar, which is a simpler approach to load testing for DevOps. Our speaker today is Tim Koopmans, who's Director of Load Testing at Tricentis. Welcome, Tim. Thanks for joining me.
Hey, thank you. Thanks for joining.
I'm going to go ahead and turn it over to you and let you do your thing now.
Yeah, thanks very much. And g'day, and thanks so much for the opportunity to talk to you all about Tricentis Flood and our new simpler approach to continuous load testing. Now, as will soon become evident, we think the future is blue, and I'll spend a good part of this presentation looking at the different options you have for load testing with Tricentis Flood. If you Google the word continuous testing, you'll find Tricentis at the top, and that's not to say we pioneered the term, but we care deeply about continuous testing, and we care about how it fits in a continuous integration or continuous delivery lifecycle, and we care about its impact on development operations processes, and it is indeed the cornerstone of much of our product thinking and approach to test automation. And if you visit our site, you'll find this, pretty common looking infinity logo, which on the left-hand side shows activities related to, say, continuous integration or CI, and on the right-hand side, activities typically associated with continuous delivery or continuous deployment. And in the middle, continuous testing seems to link those two sides together. Now, given that testing appears to be the nexus between, say, development and operations, I think it's fair to say that the quicker you can complete that testing, the quicker you can move between the two spheres of, say, dev and ops. But CI and CD to me are just common acronyms that people use when they start to talk about, say, modern DevOps practices, and testing is really common to both sides. Which is why I really like this perspective of continuous testing as it applies to DevOps. The guy's named Dan Ashby showed this on his blog a couple of years ago, and it really implies that testing is not a once-off activity. It's something that you would, say, consider all through, through all phases of development and operations. So next, let's get some definitions out of the way. Load testing, I like to really define it as something like putting demand on a system and measuring it for performance. I think that's the easiest way to describe load testing. And the word continue really just means to persist or carry on or resume. And many make the mistake, I guess, of thinking that this is all it means to do continuous load testing. We, persist with the test effort, or we maintain status quo, or we resume from the many interruptions to our load test. When, in fact, by ditching the E and adding an OUS, it takes on a slightly new meaning, and that's important to note when thinking about continuous load testing. It doesn't just mean to, say, continue or carry on. It actually means to do something without interruption. And what do you think the biggest interruptions or blockers to continuous load testing are? Well, the first big blocker is creation, and it's all about building the model and the automation logic around that, which lets you, simulate demand on the system. So I often hear from customers that say, we want to load test, but we don't know how to get started. And that's really at odds with our sort of continuous testing approach, as load testing is interrupted before it even starts. And the big blocker here, of course, is not really knowing how to create what we call a load test script. Now, this has been a long-term issue for people looking to get started with load testing, and it's ever more prominent these days with the rise of more sophisticated web applications. And I'll talk in more detail shortly about the complexities and issues around creating load tests themselves and what we're doing to circumvent these issues. I guess the common perception, though, is that one needs to build a rocket ship in order to get started, and even after it's built, there's there's really no guarantee that your tests are going to make orbit in a, some form of continuous testing strategy, let alone kind of exit the atmosphere of development. And of course, the next big killer to me, especially for load testing, is reusability. And what I mean is the ability to take the test assets that you produced in the last round of testing and then reuse them in future iterations of your DevOps lifecycle. So, it would seem obvious that you want to reuse as much as you can. However, many scripts that we create with more traditional approaches to load testing, and especially at the protocol level, they become very brittle as the application under test changes. And we're often left with the daunting task of re-scripting the same business logic that we've already solved for earlier. So this in turn puts enormous strain on load test resources in terms of the test script reuse and maintainability. And it often means that your testing cycle can't really match the cadence of the development lifecycle. And it's not uncommon to see load test efforts simply just left behind or completed at the last minute for these reasons. So in my sort of consulting career, the other thing that I always found frustrating working alongside functional teams was that much of the work they complete, say, for example, using Selenium, was simply not usable in a load testing context. And this is largely due to the approach or methodology. And they would be, focusing on simulating real user behavior from the browser. And then I would be recreating all of that same logic, but acting as a browser at the protocol level. So that meant I couldn't really easily reuse any of that business and automation logic that other teams had already solved, and I'd have to really start from scratch each time. And this was, often making compromises along the way in terms of what functionality I could cover. And it really always felt like, the complexity in terms of scripting was preventing me from load testing more realistic scenarios within a given time frame. And that gets even harder in sort of like a DevOps lifestyle. Another killer to continuous load testing are really test data requirements. And if you're trying to figure out this particular graphic on screen, the rockets actually run out of propellant. And so, often we think about, static test data in the context of a functional scenario, and we might be interested in covering certain combinations and permutations of that data to uncover functional defects. But of course, with load testing, we not only need to cover these functional aspects, but we also need enough data to really exercise the simulation model as realistically as possible. And that's without hitting things like caches in front end or back end systems. And preparing test data, extracting it, sanitizing it, or even synthetically generating it can be quite a time-consuming task. Not to mention figuring out how to, start from a known state or a warmed up condition, or perhaps resetting between test runs, for example. And these all add to the ongoing sort of complexity of your test effort, and they can get in the way of any load testing, let alone continuous load testing. And last but not least on this sort of track, test environments. Often the biggest blocker to continuous load testing because they're simply not available, or if they are available, they're incorrectly sized. And I think it goes without saying, the closer your test environments are to production configuration and size, then maybe the easier it might be for you to infer risk to production from your load testing. It's not to say that load testing on a sub-sized environment is not valuable, and it certainly can be in the right context, because not all tests need to be production size. And I often hear this debated in our performance community about, where exactly is the right environment to run load tests from? Should we maybe shift right and do more in production, assuming that we have that capability to isolate and separate ourselves from production? Or should we shift left and target non-production environments much earlier in the life cycle that perhaps are, a different configuration or size? And it really comes down, I guess, to context and objectives. So sure, if you're looking to use absolute values from the results of your load testing, then maybe a production-like environment makes more sense. But I would always encourage you to consider relative change in measurements in any environment for that matter. And generally try to avoid inferring production behavior from some arbitrary baseline. I think it's much more important to establish an empirical baseline over time to begin with, because only then, once you have consistent performance characteristics from any environment, will you be able to detect and isolate change. And if the delta between when you last tested is measured in months, then you're probably going to have a hard time anyway isolating, exactly what in your application code or configuration has triggered that change. which is why I'm a really strong advocate for testing more frequently rather than just once per year or once per quarter or whatever release cycle you might be tied into. And I think DevOps really encourages this to test more frequently. And my other advice around environments is that we're often left waiting for the next piece of developed functionality to be deployed into our test environment, which ultimately, it means our test efforts keep sliding to the right as we wait. And I feel like it is better to be, really decoupled from the release cycle and perhaps even maintain your own test environment independent of what's going on in terms of development. And whether that's in production or pre-production, and then introduce change as it becomes available. So, that's not going to sit well with more compliance or regulatory sort of load test efforts that might have a set finish by date, but it works really well with modern DevOps practices. And that's something that we do at Flood, particularly with things like CI and CD pipelines. This is a really good way to introduce change into a load test environment. So the good news is, once you solve for creation, reusability, data, and environments, you stand a really good chance of having implemented your own continuous load test strategy. And given the tools and platforms to date, this is not as easy, and I would probably argue not the norm. It takes really highly qualified people to build and sustain this type of model, which is why I often liken it to building and launching rocket ships, and ideally reusable ones like the one on screen. So it's great if you've done this, but I guess 9 times out of 10, I find customers are really struggling with either one or all of these dimensions of load testing. So this really became a holistic goal for us at Flood. We wanted to make load testing in the first sense much more accessible. And since joining with Tricentis, we've been able to leverage some of the other platform functionality like functional test automation, test data management, and of course, orchestrated service virtualization to tackle some of these other problems head on. So why do we care so much about continuous load testing? I mean, load testing, to me, it really helps find out about performance, availability, reliability, and scalability issues. And this is an ever-changing picture. So being able to continuously load test over time without significant burdens to, say, creating and executing load tests at scale is a really important capability for any team, regardless of methodology. So let's look at some of the examples that I'm talking about in terms of performance, availability, reliability, and scalability. So first up, performance, everybody cares. And I guess the most obvious dimension of this is perhaps response time. If on the one hand, your application loads in a reasonable time, like I think the one on the right is, then nobody has cause to complain. But if on the other hand, your application takes 5 times as long to load on the left-hand side there for a different customer, or perhaps your website is maybe 5 times slower than your competitors, then everybody cares. We definitely care about this dimension of performance. And we might also care about other dimensions for the same domain. So how many concurrent users are looking at this page, or how many times per minute is this page viewed? What is the sort of page weight in terms of the number of requests that are being made and the size of each request, and where are all the page components actually being served from? Or how well does our browser actually cache the page items? So performance, to me, it's really a very loose umbrella term for a whole range of application metrics that we can measure. So it's the ones that we can typically measure that we focus on. And availability really goes without saying. If your site is not available, everybody knows. Availability issues are perhaps, I guess, the worst dimension to experience as a customer, and they should feature really high in terms of your priorities for load testing. Now, reliability is a different story, and this, obviously answers the questions: does your application actually return the expected response? Or, maybe you uncover generic 5XX ranges of error codes like the one on screen, or maybe you have HTTP 200s, but you're simply showing the wrong data. Or worse, if you start showing data to a customer that perhaps they shouldn't see, and like some projects I've worked on, even worse, if you start showing other customers' data because your caching rules and validation key rules are broken. So reliability issues are really long and exhaustive, and they can be really difficult to uncover in a canned sort of scenario. So exploratory load testing, which I guess is a topic for another day, maybe a different webinar, is a really great way to delve into these reliability issues under load. And last but not least, the thing that we care about, scalability issues. Everyone really knows what it's like waiting in queues, long wait times, reduced services, incomplete transactions. These all have the knack of really driving up customer angst and frustration. And you'll surely feel the effects of this on social media when you get it wrong. So having infrastructure which is correctly sized for the workload really helps you deliver operations for a known cost. And having infrastructure which can, say, scale out or up on demand in response to increased workload, that can help you survive unexpected events. And I guess the reverse is true as well. I mean, I've been guilty of this. Being able to tear down infrastructure that you've automatically scaled out can lead to better cost savings overall. So all of these dimensions of scalability should be part of your load testing. And I sort of liken scalability as just another way of saying, modern sort of capacity management. So we know the reasons why we want to load test, and really we know what we should care about. So let's get on with the actual business of creating load tests to begin with. Now, traditionally, load test tools tend to focus on simulating demand at the HTTP protocol level, and I refer to these as protocol level users, or Plews for short. And there are really good reasons for this. I guess the most obvious being that you could simulate a large number of virtual users from a single process. And Tricentis Flood has always supported open source tools like Apache JMeter and Gatling to really help you simulate load at this level. And it was a good approach, back in 1999 with HTTP 1.1, and it's continued to be a good approach for, let's say, less complex or well-defined HTTP endpoints. So, back in the day, websites tended to make fewer requests at the protocol level, and they were pretty easy to simulate. However, I guess in 2018, the web-based landscape, it's much more complex than it was 20 years ago. I mean, whilst the websites still have the same look and feel in terms of functionality, under the hood, they've become a lot more complex than it appears. And if we think about the history of load testing tools themselves, what we saw was a lot of innovation and advances in the way we simulate load from, say, the late 90s to around 2006. However, I really feel like the innovation curve in this landscape has waned since then. And it was right about when complexity for websites started to explode. So to give you some examples of that, XML HTTP requests, or XHRs, they really became a thing in around 2006. And this is when developers started to make asynchronous calls from the browser back to the server. JavaScript frameworks, they tend to come and go, but I guess frameworks like jQuery really kicked it off here, and they changed how a client interacts with their browser. And these days, there's any number of popular JavaScript frameworks. I mean, the common ones are like React or Ember or Angular, and they really dominate the HTTP request payload. And they also have a lot of dynamic parsing and execution within the browser, which is all client side. So the list really goes on, but all of them are introducing more and more client-side functionality, and I'll talk a bit about that in a few slides. HTTP 2.0, for example, that was introduced in, I think it was 2015, and we're only just seeing support for it at the protocol level in load testing tools. WebSockets, they've been around since 2011, and to be honest, they're still a nightmare to simulate at the protocol level. So even things like HTML has changed a lot. CSS has changed a lot. You could say that the average number of requests per page has increased. Overall, the complexity is really ramping up. Even browsers themselves, this is just a timeline of the different browsers that have become available over that period. There's more sophisticated ways for, say, cookie and local storage management in the browser. Authentication and security protocols keep changing and probably arguably more complex. Even cache management in the browser is a bit more involved than it was 20 years ago. Okay, so let's break this down. In 2018, say you wanted to visit, simulate a visit to the Amazon store, you could ask, well, how many requests would that make at the protocol level? You might think it might be 10. Is it 20? Is it 50? Is it 100? Is it more than 200? The reality is in 2018, that single visit in the browser makes over 300 HTTP requests. So, simulating all of this at the protocol level, despite having a really huge barrier of entry to those looking to get started with load testing, it also carries a huge maintenance overhead for those that are more experienced with load testing. And it's not uncommon to really throw away your load test scripts after every release, because so much can change in a modern web application when application code is deployed. And this makes it really difficult to match once again, the cadence of your load testing cycle within sort of modern DevOps practices, they kind of drift apart and become out of whack. So in short, I think everything has changed in the web-based sort of landscape, and have the load testing tools changed? Well, I guess load testing tools they've attempted to keep pace by focusing on the protocol level and trying to solve problems with things. You'll hear things like, protocol recorders, or, there'll be little proxy recorders that are in your browser, or smart correlation, for example. But what does it take to actually, if you have a think about it, what does it take to simulate load against a modern web application? And if you haven't done that before, I'll show you that in the next few slides. So at Flood, we like to use SAP Fiori because we think that's a really good benchmark for modern day web application complexity. So if we wanted to simulate user activity, like maybe just visiting the portal, which I'll just wait for it to load on screen. Yeah, this is from Australia. And then clicking on my inbox, we can take a sneak peek under the hood to see what activity looks like at the protocol level. And you can see this, you can see in this animation that there's a ton of requests being made to the server. And all of these would need to really faithfully simulate if we're looking to just do this at the protocol level with JMeter or Gatling, or any other commercial load testing tool at the protocol level in the market today. So I guess it seems obvious at the protocol level, we would want to record and play back that traffic in a load test. And this is the default starting point for a lot of people getting into load testing. And in fact, this is where many commercial and even open source tools have invested all of their research and development time into. And for a while, it really just became the battle of the best recorder, let's say. But what exactly are we dealing with at this level? Like using that SAP Fiori demonstration as an example, we can take a look, and we can take a snapshot of 2 recordings for the same user. So doing the same business transaction, and then just compare them side by side at the protocol level to sort of see what's changed, do a diff on what we'd need to account for in our load test scripts. So let's do that. First up, J session IDs. This is really a piece of cake, and any load tester, young or old, should be able to spot dynamic things like session IDs in a request payload and then note their differences. I guess this stuff is the bread and butter of load testing, and it's relatively easy to find and extract from, say, a response body or a cookie or a header, and then subsequently use these in future requests. So pretty straightforward. I don't think anyone has too much difficulty with that concept. Cross-site request forgery, as you probably know, also known as one-click attacks or session writing, and abbreviated as CSRF or CSRF. We can observe that the application is sending like CSRF tokens with each request. So once again, this is pretty much bread and butter for load testers. It should be easy enough for an experienced load tester to create some form of rule to extract this information and apply it in future requests, based on the name attribute, for example. And this is where things get to, start to be a bit tricky. We can see in one of the recordings that some of the requests to what look like, it looks like static fonts, which were present the first time through, but not in the second recording, or at least not in the same position. So, now we have to make some conscious decisions in our load test scripts about, whether that's important or not. And it might not be a big deal because we could say, well, it's a static font, who cares? But it's something that we need to account for, and it's a good demonstration of, say, the varying cache behavior of a modern browser. And we can probably move on to something more complicated. The differences in this recording, this part of the recording, I guess, are interesting because there's something present in the second recording which isn't present in the first. And we can't really be sure about what the importance of this key value pair is, but it does look like it's something to do with a dynamic AJAX request, judging by the XHR header. And that probably means that the browser was passing and executing some client-side JavaScript at the time. And we can also observe that I think it's the max data service version value is different, 2.0 instead of 3.0. And at this point, we're starting to have, really no idea on the significance of these changes and, whether we need to account for them at the protocol level. And I guess our best bet would be to keep recording iterations and then try and figure it out. Or, alternatively, we might have the luxury of asking an in-house developer about what they actually mean with these variables. But in this case, it's a packaged application, so you're kind of just stuck. You'd have to suck it and see. And okay, now on screen, whether you're a young or old sort of load tester, you're probably starting to get confused. We can see more XHRs present in one recording and not the other. And it definitely looks like some form of, SAP business logic this time around, perhaps being exercised. And, we can't really be sure, but we're going to have to, start cutting corners in our script because we need to account for all these changes. Otherwise, we're going to have to sort of painfully investigate what all of these calls mean. And I guess it's back to the manual you would normally go, but once again, this is a packaged application, so you don't even have the luxury of, being able to read up on this stuff. And now we're kind of getting to the guts of the recording, and we can see, what clearly looks like changing post data related to some form of, SAP business logic. And we can, of course, remove the encoding from it pretty easily and break it down into callable statements. But this level of logic is definitely not documented, so it's going to take some time for trial and error. And this is where the time sinks start to creep in to really, figure out what it actually means and how best to simulate it with dynamic parameters going forward. And it's kind of exactly this sort of stuff that keeps changing between every release. So you're going to have to keep accounting for all of these changes. And, at the end of all that, having observed the differences between two recordings for just two simple user actions, visiting the portal and clicking on my inbox, we can kind of relax knowing that there are only 1,365 changes in the request payload that we'd have to account for. So don't worry, we've only got another 12 more business scenarios to script, and each with multiple test cases and test steps, and we probably ordinarily be finished in 4 weeks or less. So you can imagine how much that sucks for a sort of DevOps lifecycle. This is a huge pain for many customers, and it doesn't really matter if you've got over 10 years or more experience writing scripts like I do at the protocol level, or even if you're new to the game. The challenge is really hard, and it takes a lot of effort to really first build and then confirm that the protocol level script is actually doing what it's meant to do at a functional level. And at best, it's only a really rough approximation of how a real browser would perform the same logic on its own, including things like I was talking about earlier, say session handling, cache management, authentication, security, and of course, all of the JavaScript parsing, execution, and rendering to the browser. So you have to account for all of that complexity in your scripts. So, I guess over the last few years, I've often asked myself, is protocol level load testing heading for some type of extinction event? Will the modern web application comet that's spinning towards our perhaps prehistoric load testing approaches, gaining in speed and size as it collects JavaScript frameworks along its path, finally wipe out protocol level scripting with a huge shockwave of complexity? And I think the answer is no. I don't think the dinosaurs are dead yet. And whilst I've spent a good part of this presentation showing you why, say, protocol level users are not particularly great at load testing modern web applications anymore, there is still a ship for them to escape that event. And if anything, it's one that focuses on API level testing. API architecture is ever more present than before. Whether that's a big ball of microservice components with RESTful APIs joining them all together, or maybe it's just a ton of devices, mobile devices talking to some well-defined HTTP API. These are the sort of use cases that protocol level testing is, of course, very well suited for. So I guess the message here that I want you to take away from that little rant is you really should be picking the right tool for the job. Right, so where does that leave us if we want to test real user behavior in a browser? And I think the answer is probably obvious by now. Browser level users, or Plews, as we like to call them for short. And I'll spend the rest of the presentation sort of showing you, what we've discovered so far, what we know doesn't work very well, and how best to integrate browser level users into your load test effort. So let me say that this concept is not really new. In fact, I think it's a bit of a revival, and in many ways, we've always tended to favor, tests in general at the UI layer, even though we kind of put it at the top of the automation period. But I think of pyramid, I should say. I think there are many reasons for this. The UI gives us really good fidelity in terms of understanding user behavior. After all, it's something, we're simulating actions at the same layer that the user interacts with. So if I say I clicked on the green approve button on screen there and saw its status change from, say, pending to ready, then I know with a fair amount of certainty that what I've simulated is actually representative of real user behavior or expected user behavior in the browser. And if I measure the time that it took to complete that action, and it happens to be 4.6 seconds, then I have a fair understanding of response time that a user can expect when interacting with that component. Now, we can of course measure all of that at the protocol level as well, except when I'm talking about that example, that action actually made 83 requests over the wire. So now we have to we start to lose fidelity in terms of how do we actually measure that and observe, say, response time. And if I break that example down a bit further, just looking in Chrome Tools here, we can of course observe what's happening with each individual protocol request. I mean, the time you could say seems to be about 400 to 500 milliseconds per call, but there's a lot of white space or pause in between those requests. And as the browser is executing requests in a particular order, and more importantly, what would be missing from the protocol level script and not from the browser level is an indication of the time in terms of things like loading content and executing scripts or rendering components and painting them to the screen. So we can only start to measure this type of behavior if we're testing at the same level as the user, and that's really the browser level. So for the last couple of years, Flood has been supporting execution of Selenium-based scripts in a load testing context. And I know it sounds kind of crazy, but I'll explain the reasons why. Whilst it was a pretty naive approach, but it was still sort of favored by a small portion of our customer base because of the sort of complexity issues that it solves. It really brought more problems to the solution that you don't typically want within your load test though. And I guess the first thing was size. Selenium was never really designed to be a distributed load testing tool. In fact, in order to run these tests at scale, we would distribute copies of Selenium standalone server, within a Docker container, have another side container, sporting the browser of choice like Firefox or Chrome, for example. And then by the time you get the containers running alongside each other, you're looking at a couple gigabytes of disk. It's not really a problem for cloud-based architecture, but you're also feeding, hungry JVMs with plenty of memory and competing with each other for CPU on top of, the browsers themselves. And this creates a fair bit of resource contention, which means it kind of limits how many browsers you can effectively simulate for a given resource. Another issue that we found with Selenium and WebDriver in general is that it's pretty opinionated, and those opinions are really geared towards best support for functional test automation, and I would say less so for load testing. So that kind of presents a conflict of sorts. And a good example is HTTP status code support, for example. WebDriver doesn't let you inspect the internals of a browser by default, so you have to implement a proxy of sorts and then route all of your traffic through the proxy and inspect it from there. So it gets clunky really quickly, and it's even more difficult to scale than, say, a distributed load test scenario. But why would we be even interested in HTTP status codes in a browser level load test anyway? I mean, I just said that protocol level is hard, but of course we're still interested in what the browser is doing under the hood. Particularly if any request that is making a failing for, say, reliability, scalability, or availability reasons, we need to be informed of those in case the browser representation is kind of masking them. So doing this reliably with Selenium was a pretty difficult challenge. And I think the last issue that I was kind of frustrated with was timing. So once again, Selenium is not really geared towards load testing. So if we want to interpret response times, we then need to hijack the browser's JavaScript engine and hook into the navigation timing, or alternatively use the user timing specifications. And they're actually great ways to get fairly detailed timing information from the browser. You'll see lots of examples out there if you Google this. But the downside is that it only works by injecting or running additional JavaScript in customers' code, and that's obviously less than ideal. And additionally, things like the navigation timing spec, they're not particularly suited to, say, testing single-page applications where much of the activity happens after the load event. So that means you get inaccurate response times or no response time at all. And I guess you can supplement this a little with the user timing specification, and that relies on marks and measures. But once again, you need to modify the customer's code, which is less than ideal. And many customers simply don't have the facility to do this, particularly if they're testing some form of package application like Salesforce or SAP Fiori, for example. And at the end of the day, it always seemed to us that we were kind of bending Selenium against its will. And it certainly solved, I guess, many customers' complexity issues when comparing browser level to, say, protocol level scripts. But we weren't entirely happy with it as a browser level load solution for load testing. So towards the end of last year, Google released Puppeteer, and this is a Node.js library. It provides a high-level API to control headless Chrome or Chromium, and it does this over the DevTools protocol, and it can be configured to use full or non-headless versions of Chrome as well. So we were really excited by this release, and as most things, you can do most of the things you can do manually in the browser can be done through Puppeteer. So that includes things like generating screenshots and PDFs of pages, or even using single page applications, which is really an important win for us. You could do, of course, automated form submission, UI testing, keyboard input, and so on. You could also do things like timeline traces of your site to help diagnose performance issues in a headless context. So with this great functionality, we thought, well, it would be awesome if we could continue enjoying the style of Selenium scripting, let's say, combined with the power of Puppeteer. So Flood Chrome was born. We're actually after a better name than this. We haven't got too creative here, so I'm open to suggestions. But we didn't just choose one or the other. We in fact merged two approaches into one. And you can use Flood Chrome today and try it out by visiting chrome.flood.io and just following the demonstration that's in the script there. So a little bit about Flood Chrome. It uses TypeScript. I mean, that was sort of influenced by Puppeteer, and that uses the same syntax and semantics that I guess millions of JavaScript developers already know today. Now, the good thing about TypeScript is that it compiles to clean, simple JavaScript code, and that code is actually run in the Flood Chrome Node.js engine, and it borrows much of its semantics and style, as you can probably tell on screen, from the popular Selenium JS framework. So the DSL itself is relatively easy to understand, for anybody that's kind of new to programming, or especially coming from an automation background. And at present, we're kind of developing all of this code base as a closed source project, but we do have plans to open source this in the very near future. So it's still in public beta, but the feedback we've received so far has been great. And as we like to release early and release often at Flood, we actually started to trial this late last year, with a customer who had an immediate need to test a really high volume ticketing website. And that customer was preparing for the sale of concert tickets to, I think it was the Eagles and Harry Styles concert. So being a partner with American Express, they had really high expectations in terms of being able to not only service the load but also have a good customer experience. So I like to use this study or this use case as a really good example of a customer who's picking the right tool for the job. They actually used protocol level scripts written in Gatling, and they use that to sort of target well-defined APIs on the back end that kind of spins the wheels up. And in conjunction, they also used browser level load scripts using Flood Chrome to kind of map out the real user behavior in terms of ticketing flow, because you can imagine there's kind of different paths through the application depending on the sale of the event. So what you can expect when using Flood Chrome is the same dashboard that our customers already love for protocol level load testing. So it's got some additional features aimed towards browser level testing, of course. And aside from the obvious things like response time, concurrency, transaction rate measurements, for example, we also showed a detailed breakdown of any headers or traces at the network layer. We show assertion results or errors, as well as screenshots of each transaction under load. So that makes it really easy to visually identify any errors or abnormal behavior of the system under test, including giving you some clues on where to start looking. So in the example on screen, you can see a couple of screenshots there at the 4-minute mark. And they clearly look different to the rest. And when you zoom in and have a look at those, they're actually triggered some form of rate limiting. So that's something that we weren't expecting in the application under test. And we're also looking to expand on these features in the near future. So we'll be including other metrics around response time performance. We really like the way the sort of Chrome Real User Experience Report is structured. So in particular, the way things are passed and rendered to screen, as well as some of the metrics that help break down, say, request throughput and cache performance and so on. So as I start to sort of tail off this presentation, I just want to quickly talk about what's happening with Tosca and Flood. And in May this year, we offered, I guess, the reality of a single test case definition for Tosca customers. And this is where you can take existing functional automation test cases and reuse them as is in a load test scenario. So that makes it dead simple to scale from one user to thousands of users, and it gives Tricentis Tosca customers a really simple and straightforward way to execute and analyze performance over time. So Tosca itself has some new functionality, and it lets you define and manage your load test streams from within the application. So there's no need to modify existing test cases, and you can just simply reuse the same test cases from your automation scenarios and then apply them as load test scenarios. And from that, you can do things like concurrency, geographic region, ramp up profile, step timing, and scheduling, all from within Tosca. So when you're ready to run the load test, you just hit run, and then the Tosca Flood integration takes care of the rest. So I guess it kind of begs the question, what does Tosca's model-based test automation really give our customers, and why would you bother with Tosca if you can just use Floodchrome, for example? And I like to say that, if you could imagine a Lego set where you'd have to 3D print all of the Lego pieces themselves before you're ready to, start building your model, this is kind of what classic test automation means to me, especially with open source frameworks. So, before you even get down to the business of automating things with Selenium, you need to start thinking about, building the framework first and how you're going to handle test data, how you're going to manage code, what the models are going to be, what the keywords and all of the attributes and so on. So Tosca or Tricentis Tosca really helps you define the test cases. It's got a scanning engine. The automation model contains the automation logic, and that's decoupled from the test logic, which is specified as a test case. And once all of the required models are defined, they can just be used or reused to execute both manual and automated test cases alike. And all of the models, of course, are dynamic. They're synchronized with the application and the test. So that means any updates or changes can be reflected back in the test cases. So it eliminates much of the sort of maintenance challenges and with the traditional approaches that I outlined earlier in the presentation. And I guess what that means in layman's terms is I can really dive straight into the practice of building reusable test automation. So there's no need to build the building blocks themselves. They're already there. So you just assemble them into the model. That represents your sort of business logic. And in fact, the underlying technology that we're actually using to run Tosca on Flood is Floodchrome itself. So in effect, we're saving customers from needing to really write actual code. And that option still exists for Flood customers without Tosca, where they can still choose whatever tool it suits. So if you want to hit at the protocol level, you can still use JMeter or Gatling. And if you want to hit browser level, you can still use Floodchrome, of course. For Tosca customers, it means that they can probably, elevate the discussion from just purely code or script and start to build and, reuse easy to maintain modules that represent business functionality. And of course, we'll support browser-based test cases that are defined in Tosca and then executed at scale and Flood. And it also means that we can support API-based test cases in the same fashion, which are also executed at scale and Flood. I should say that API-based test cases are simulated at the protocol level because there's a nice one-to-one fit there. So just looking at the time, I'm going to start to finish off this presentation with a brief mention of our cloud capability and where we can generate load from. So we currently support 15 geographic regions. They're linked to Amazon Web Services. And later this year, we'll be supporting up to 36 additional regions through Microsoft Azure. And we're also adding another 14 regions from Google Cloud. So we're already working with some select customers and also supporting a hybrid cloud model and these are the sort of customers that don't have applications necessarily sitting in front of corporate firewalls, for example. And I guess the really nice takeaway about Flood and I like to say as a cloud-based distributed load testing platform is that it gives our customers a really unprecedented economy of scale. So you can start and stop infrastructure on demand, and you can dynamically scale out to meet your constantly evolving load test targets. And most of our competitors, they're going to be forcing you to pay per test or simulated user, which I don't really think is a great fit for DevOps. It kind of makes it really difficult for you to estimate the costs and get the return on investment. In fact, whenever you're sort of starting a load test effort at any stage through the DevOps sort of life cycle, you kind of don't know this stuff in advance. So it makes it really hard to plan for. But at Flood, you just simply pay for the infrastructure that you use. So we don't mind how many tests you run or how many users that you simulate. And of course, we call this test-friendly pricing. And it's one of the reasons I think customers really love using our product. So, wrapping up this presentation, I mean, at the start, I detailed the really big blockers to continuous load testing around, say, creation, reusability, test data and environments. But the key message I want you to leave with is to really focus on maximize reuse of functionality. And by that, I mean, as part of your continuous load test strategy, you should be adopting tools or even better, a platform which really focuses on reuse. If you can reuse functional test assets in a load testing context, and that's a great capability, and it's going to save you a lot of time in terms of test case creation and reuse. And if you can leverage tools, once again, that help you with, say, test data management or even virtualization of test environments, then you stand a really good chance of actually implementing your continuous load test strategy. And if you ever feel like your load test efforts are disjointed or overly complex, or very time consuming, not making many decisions at all, then it's probably a really good time to start to review your strategy and approach in general. And with the Tricentis continuous test platform and also Tosca Flood, we're not saying that, automatically you become a performance test engineer just by using the product. And we're certainly not suggesting you need to be, because, these are really skills that take training and experience to develop over time. But we can really all talk about performance, and I would even argue that it's intuitive, and most of us have a really good feel for issues around, say, performance or availability, reliability, and scalability. And personally, I really think that the future of load testing is mostly blue. I would say protocol level isn't dead, but we need to start being smart about our tools and methodologies as we tackle modern day web applications. So in conclusion, and referring back to the theme of this presentation, in terms of describing a new, simpler approach to load testing, especially continuous load testing for DevOps. So I covered basic definitions of load testing and the dimensions that you should really care about. I also covered in detail the challenges of continuous load testing and protocol level load testing, including script complexity, and I also pondered the sort of extinction event for this style of testing. And we confirmed that it really is about choosing the right tool for the job. And I guess protocol level testing still has a place for API level testing, for example. And I also shared with you, the sort of evolution of our own browser level user approach from early trials with Selenium to the purpose-built Flood Chrome, and highlighted where we're going with Tosca Flood as a whole and how that kind of fits into the whole continuous load testing story. And that concludes my presentation. So I'd now like to welcome any questions you might have.
Great. Well, this is the time for the questions, folks. So if you have a question, excuse me, for Tim, please go ahead and use your control panel and submit your questions, and we'll get started right away with those. First question, how do I know if my load testing should shift right?
Yeah, thanks for that. I always get this question. And let me just go back to one of these slides. So, I think it's this slide. Like people are saying, like, should I shift right? Should I do more stuff in this side, or should I shift left? And I guess it's like what I sort of encourage customers to think about is I don't think it should shift in any particular direction. I think this slide is really great because it sort of suggests that there's all types of load testing or testing in general that you can do all throughout this life cycle. So you can be talking about performance requirements very early in sort of like the planning phase before you've even written code. I think performance testing has a really good fit with around this sort of area. As you sort of writing code, you can look at sort of more repeatable, maybe smaller size types of performance tests. And as you build stuff and release it into production, there's definitely like a good fit for doing load testing here. It's part of some automated CI/CD delivery pipeline. You're definitely interested in, say, performance all the way over in the right in terms of operational domain and monitoring and alerting in production. You might observe things that are happening in production that you want to prevent from happening again. So back to the original question, when should I shift right? If I use Flood as an example, we kind of shift right whenever the sort of size dictates. We might have a sort of operational issue that we've identified that's just impossible to sort of recreate in a lower level environment, and but we can sort of recreate pretty safely in a production environment. So that's kind of like how I get influenced about which direction I go. But I guess the main point is to always consider load testing, not just try and pin it to one particular activity or direction.
All right, great. Next question is multifaceted. Is there mobile, native, or browser emulation? And then is there any kind of network virtualization?
Yeah, so to answer the first part, and you might have to remind me for the second part in case I forget.
Sure.
Yeah, mobile level users, I'd love to actually have something like that on our roadmap. As another thing in addition to Plews, because I think it's a different context, and whether you're using sort of device farms or emulators or even simulators, I think the reality is for me, and when we start to think about roadmap for this for mobile level users, is I feel like the tool landscape isn't quite ready yet. I think there's some really exciting projects like Appium, for example, that's got a lot of potential, but I would be sort of concerned about how we can sort of do this effectively, how we can sort of tie into the tools and hook up with reporting and all of the other stuff that needs to happen to make this a reality. So we've definitely got our eye on it in terms of a potential candidate for our roadmap, but we haven't got a fixed plan yet on how we would do that for our customers. And
Okay,
the second was network virtualization, I think, was it? Yeah,
correct, yeah.
simulation. So yeah, a very early version of Flood, we actually had uh, network emulation tied into the grids, the distributed load test infrastructure. So we gave our customers the ability to simulate, different types of network conditions. So maybe like a 3G network with high packet loss and sort of long tails on latency. But the reality is, I feel like even though we built that feature, we actually ripped it out because it wasn't that popular anyway. Most of the network emulation that you do these days is still in sort of user land in terms of where you would do it in terms of a simulation. And it kind of didn't make sense to be trying to squeeze, say, 1,000 users through a simulated 3G network, for example. I really feel like the browser tools that you get for free, so being able to simulate different network conditions in Chrome, I could probably show you, but if you just Google that, there's lots of ways to just visually eyeball performance and see how that impacts one user. I think that's good enough. I don't think you need to necessarily run a load test through the same, because it's if you have like ping latency of 800 milliseconds, I can tell you without running a load test that performance for a website that makes 300 requests is going to really suck. So you don't really need a load test to confirm that, if you know what I mean.
Okay, the next question, maybe a spin on the first one, which is, can I have load testing running from a mobile device?
Not well. I guess they're asking, like, they're not really asking like, can I look at Flood from a mobile device? Because of course you can do that. It's a browser-based application, but
Mhm.
yeah, like I don't. Yeah, once again, I don't really have an answer. It's something that it's good to hear these questions. I mean, it's definitely another tick against feature development, but we don't really have an answer for mobile level performance testing yet. I guess the most common thing that customers are doing as it relates to mobile is they're kind of picking on the back end HTTP APIs that mobile devices inevitably talk to. So that's normally the route that people are going. I think also this question might be asking, like, how do you assess performance characteristics from a mobile device? And once again, without going to sort of specifics, there's definitely ways you can sort of do that,
Mhm.
but you don't need a lot of devices to sort of confirm that.
Okay, all right, great. Next question, how is it possible to analyze performance test results continuously without it becoming too time consuming?
Yeah, that's a good question. So I think the trap and even early versions of our application, uh, it's sort of like everyone sort of makes a mistake that I guess again, maybe it was driven from overall complexity, the sheer effort and will it takes to get a load test happening. People tend to just focus on one load test or 1 out of 10, and then they get the results that they're after, and they park it away and never think about load testing, and they sort of breathe out a sigh of relief and continue on with their other stuff. But of course, that's not really what continuous load testing about is to me. And I think continuous load testing enables you to do, well, it should enable you to make lots of decisions. And the only way you can make lots of decisions is to have data. And of course, the only way to get that data is to build some form of empirical baseline that I was talking about in my presentation. So for me, to look at stuff continuously over time, it doesn't mean to look at every load test that's going through the CI pipeline, for example. But it does matter that I am doing load tests, big or small, through that pipeline, because once again, I'm building that baseline, and when things change, then hopefully you've got the historical data to go back on and say, what actually changed? Like, what was the Git commit or the SHA that sort of introduced this performance regression? And if you're back in the more the traditional world of only doing a load test every now and then you're pretty much knackered. You don't have any starting point to go and find out or isolate that change.
Okay, great. The next question is, let's see, can you give an example of the types of complexity issues you are solving with browser level user testing?
Yes, I can.
Okay.
Yeah, that's a funny
You,
question. Yeah,
scared me
I
there
think
for a second.
I was just trying to find the slide. This is the complexity, right? Like you can't really underestimate this. This is what will bite you in the butt. Um, this was just a couple of user actions in the browser, and as I won't go through all the slides again, but getting to this point took a fair amount of effort, and I can skim through it pretty quickly because I've got lots of experience doing this, but this is where the wheels sort of fall off, and to be honest, what happens with most sort of web apps or modern web apps is this change just keeps increasing. Like it's you solve it for this release, but then the next sprint the devs go and change a whole bunch of stuff, and then all of your load test scripts break again because you're doing everything at the protocol level. So that's where this is the time sink, and that's where the complexity sort of creeps in. So you could say, well, yeah, I know how to handle JSession IDs or view state. I can do that. That's easy, but it's just the sheer volume of it, and despite what people say, like a lot of competitors will say, "Oh, we've got the smartest correlation engine in the world," but when you're trying to like find, maybe you're just trying to swap out an integer value and just trying to find the value one, well, you can imagine how many times it's going to appear in your code, and then you have to start putting boundaries around it, and et cetera, et cetera. It gets increasingly difficult. So yeah, it's a time sink. That's the complexity issue, I guess, and that faces every load test scripter at the protocol level. And I think anyone that's sort of attempted that would be familiar with it.
Okay, all right, great. Well, that is all the questions that we have, and which is good because we're just about at the top of the hour. I do want to thank everybody who did submit a question, and also thank the audience for joining me today. Just a reminder that today's event has been recorded, so if you missed any or all of it, you will be receiving an email follow-up with a link that will take you to the webinar on demand. The webinar is also going to be housed on the DevOps.com website. So if you can't find your link, or you didn't get a link or whatever, just know that you can go to the DevOps.com website and get to it there. Also, while you're at DevOps.com, please take a look at the other webinars that we have both coming up and on demand. Hopefully there'll be one or two there that pique your interest. And I do want to thank Tim Koopmans one more time for giving such a great presentation. Thanks for Tim, and thanks very much for getting up early, being in Australia. It's Friday
Yeah, no
morning for
worries.
you there, so thanks
No
very
worries.
much for taking the time.
Yeah,
Again, if you guys have any questions regarding Tricentis, be sure to check their website, and I guess that's about it for me. I'm Charlene O'Hanlon, moderator for the event, and I'm signing off. Have a great day, everybody.